Hello? Are you on?
Oh, yeah, I hear you. Um, Dr. Nakano?
Oh, no. Well, there it is.
Dr. Nakano? Hello? Can you hear me, sir?
Hello, how are you? This is linear algebra, right? Linear algebra, excellent, yes. All right, let's see. Okay. Uh, share screen. Here's all this stuff. All right. Stop share. Oh, very good. Okay, let's over things here. Oops. Paused. Not resume share. What's going on? Let's try it again. Screen share. If I can get this thing to work. Let's try it one more time. better. Okay, what did it do now? Shared window to the front. Sharing. This is terrible. Take that off. Okay, let's see. Connect your iPad to the computer. Okay. Stop sharing. Screen share. What's going on? When prompted on the iPad, use Windows. It seems to be stuck.
Hello?
Sorry about this.
Is my mic working?
That seems to be okay. Okay, first of all, can people hear me? We're out there? You
Oh,
can
yes,
unmute.
I can hear you.
Yep.
Can you hear me?
Yes.
Let me see for a second. Can you hear me? Yes? Okay, good. All right, you guys can obviously hear me. Right? All right. Okay, so for some reason I can't get this darn iPad to kind of connect. So what I'm going to have to do is I'm going to have to sort of, well, let me try one more time, and then if not, we'll have to figure something out here. Okay, so screen share. Okay. Okay. It seems to go off for some reason. Oh great, I tried this beforehand. Okay, let me go check something. Okay, go ahead. I'll see how I do.
So does it show up as charging?
There it is.
All right. I mean, it seems to see it.
No,
Are you in Zoom?
I'm in Zoom right now.
You're not logged in, it doesn't look like.
I have people who are on this side over here.
Oh, stop share,
Okay,
share screen, via cable,
okay,
share.
all right.
I mean, it looks like it's shared.
Yeah, but I tried it before and then they said that you have to do a trust or something like that. And usually it comes up on my iPad. And I did it like a couple of days ago. It seemed right.
See, we don't have one of these either, so this is all new for me.
Okay.
Can you log into this? Can the people on the other side see your iPad or no?
No,
Here,
it
let's
looks all
stop the share,
right. Okay, so
just
yours,
in case.
okay,
Okay, so if we do share, this one,
yeah, I tried it.
there,
Should say trust on here. That's the thing. Okay,
I mean, that's shared.
but then it goes off. It just cuts out.
Reboot this,
Right? I'll reboot this.
hold the button down on the side.
Put the button down on the side. Like this?
So, yeah.
It's a volume.
So how are you logged into Zoom? Because you have all this, this is up here, this is
I'm
up
just
here.
logged in via the UGA Zoom.
So you didn't start Zoom this way?
No, I didn't. I started through the UGA Zoom.
Okay. But it should be calling this.
Okay.
I don't know why there's not a trust.
If not, I brought my stylus. If you can just set me up on one of those, the Zoom pad, and I'll be okay for today. I'll work with it.
See, it's wanting you to sign in. So try, maybe that's what it is. Try logging in.
Okay.
I'll do this. I know, I see that you have participants there, but this thing, this Zoom is like saying, hey, sign in.
Good.
Not sure what-
Let's try this again.
Not sure what's going on with that. Okay, so allow.
Okay.
Okay, so now let's see, let's go back here. Let's try this again. Share. Yes. It is connected, right?
Yeah.
Oh, not charging. I wonder if it doesn't like. Is there another USB somewhere? It should work. Hooked into this, but
Yeah, it's weird because
I know I've seen Brian Bowe do this, so I know it works this way. See that thing saying,
okay. Now, I'll cut out or
looks all right. Let's try.
try on. No. I did it again.
Not sure what's going on. Sorry.
See if I got it. Yeah.
This works.
That works?
Yep.
Okay. So how do we just tip it down so we can actually see it? Okay. And, okay, so can people see me right?
Yeah, you can't put your palm down though.
Whoa,
Can't put your palm down.
okay,
This is not an active screen, so You have to be floating above.
All right, I'll float above. I'll try my best. Okay. All right, so sorry about this. We'll try to get everything working with the iPad later on.
Will you log into that for me? And I'll see if we can do it a different way.
Okay. I came in here like a couple of days ago and everything was good.
Let's go here.
Okay.
Let's go here.
So maybe I should start class.
So I'm going to share.zoom.us.
Yeah.
You should just have to enter the meeting ID here for that, and then this should just show up as a writable device.
Okay, so let's see. Maybe we can try that. That would be much better.
Let's just stop share. Here's my ID.
Okay. That would be great.
989 456 2173.
Please.
You have Zoom installed on here?
Yeah, I think so.
Nope.
No?
Look it. That might be why it doesn't work here. Plugged in.
Oh, okay.
Yep, not installed here. That's probably the problem.
Oh.
All right. Now we got Zoom.
Okay. So
We're getting to the root of the problem.
Let me just go over a few things. Okay, so let me just kind of work with this now. Can people hear me on the other end? Can people hear me on the other end? Say yes.
So it
Hello?
looks like this is the sharing is working.
That's working now?
Yep. This Zoom wasn't here. That was.
Oh, okay, great.
All right. Cool.
Okay, cool. All right. Oh, it went out again. Darn. What is going on?
All right. Well, this other way will work then. Menu. Okay. Oh, wait, recording.
Okay. All right, so let me just kind of go over a few things so we're not wasting too much time. So first of all, did you guys get the syllabus at all? Okay, so I'm Dr. Nakano, and so I've given you a syllabus for the entire semester. And I tried to do this so that the homework is given sort of week by week, okay? So I believe the first homework is due a week from next Wednesday. Okay, I forgot what day that was. I think it's like September 1st or something like that. So what I'll do is I'll actually have the grader sort of set things up so you'll just turn the homework in online. Okay, so what you'll do is everything is going to be handwritten in this class. There's no
It's
web
really hard to
information.
hear you. Can you stand closer to the mic, please?
So what you can do is you can do your homework on like a piece of paper, and then once you're done, you can either scan your homework, or you can take a picture of each page, and then just submit your homework. Okay, so I think it'll be fairly easy. Hopefully we'll have less trouble than we're having over here. Okay, so just some general guidelines for the class. So we're going to have 2 midterms. So the first midterm, I think, is listed in the syllabus. And so each midterm will be worth 20% apiece. The homework will be worth 20%. So the homework is like having 1 midterm. And the homework will actually will hopefully help you to prepare for the midterms too. So my hope is that by doing the written work, will help you actually prepare and you're sort of more looking to actually be on the midterms. And then the final, we'll have to sort of figure things out a little bit. as we'll be doing things, everything online at that point. Okay, so I'd just like to go over the list here of people. So if I call your name, please just raise your hand. Ali here. B. Great. Biden. The Belgian. Okay, Bell on the Bell. Borisek. And Brad Burke. Okay, Esther. Good. Sadiq. And Eliza.
All right, got it working. This is what you have to do.
All right. Okay, so,
So two things.
yeah,
And in your meetings under this advanced screen sharing,
yeah,
you have to say all participants,
okay,
right? Only you,
okay,
right? So then I joined the meeting with this and said, share the whiteboard.
okay,
Does that make sense?
all right,
So this is just literally sharing the, I want to do leave, stop sharing.
oh,
So I said, share whiteboard, but you
Okay.
have to turn on sharing. So
Okay.
this can,
okay. Can I share actually something else on here?
yeah, so you just do that guy, stop.
Okay. Just, so, in
So
order,
this is in the meeting.
okay. So can I just share something on my iPad right now?
Mhm.
Okay, so how do I do that? Just go back?
Well, no, you would go up here to sharing
Okay. And
and
then
then choose.
screen? Which one?
I mean, what are you trying to share?
I just want to share something off my iPad.
I mean, if this is all you can, like, is it a PDF? Is it
Yeah, it's a video.
in iCloud or,
No, it's just on.
I don't know if you can do that.
Okay, well, anyway, well, let's just do the
So you would want to do that stuff over here.
Yeah, okay.
with the PDF here.
I'll work with it later. So,
Yeah.
so right now, I just want to get back to the screen. Let's see, whiteboard, right?
Yep.
Okay, and I could just write on here like.
Correct.
Okay.
Yeah, so
Do I have to worry about the palm?
no, this is palm rejection.
All right. Raise,
I was just trashing.
just clear. Okay, just don't make mistakes.
So.
All right, we'll try it.
So I don't think this has to be plugged in now, because this,
Okay,
I opened Zoom and I gave it the meeting ID, the iPad, and said, join the meeting.
okay. Well, we'll work it out. Okay, let me just finish this off. Okay, so Daniel Gilbert, Alexis, okay, great. Young Hu, sorry. Nikita, Carlos, great. And Chris, okay, and Reese Meller, okay, great. And Kenya Mays. Okay, I think I've gone up to where we're supposed to go. Okay, great. Okay, so let me just go over here so people can hear. So this is just a general announcement about COVID. So you probably have heard this many times. So, you know, we have to practice physical distancing via the seating modifications over here. We have to have face masks. You know, we encourage you to, you know, do like disinfecting measures. So if you want to wipe down your chairs or seats, that would be really nice to do too. So if you happen to test positive or know anyone who has tested positive, they should record the positive test at Dog Check. Okay, so there's a website for this. Okay. I'm not supposed to disclose the identity of any student who has tested positive or developed symptoms for COVID. Okay, so there's supposed to be a certain amount of privacy that's involved. If you receive a notification of a positive COVID test 19 here, you should sort of dismiss yourself and sort of record this in Dog Check. Okay. And I think that's about it. Are there any questions on this? Okay. Good. Okay. So let's try to do a little bit of linear algebra now, and I'm hoping to sort of take care of these technical problems by Monday. So can everyone hear me out there? Everyone hear me?
Yes.
Okay,
Yes.
good. Okay, so so this class is about linear algebra. So and of course we're in Math 3300. Okay, so in linear algebra, there's a theoretical aspect of linear algebra. And then there's also a computational aspect. So there are a bunch of ideas that we're going to present in this class. And so some of these ideas you've actually seen before. So the first idea we're going to start with is the idea of systems of equations. Okay. And then what we're going to do is I'm going to introduce some examples of systems of equations. And then what we're going to do is, because just writing out a system is kind of cumbersome, we're going to introduce a more convenient way to express a system through what's called matrix notation. Okay, so we'll be able to actually transfer ideas, back and forth between systems of equations and also matrix notation too. Now, within the context of like all this sort of setup, we actually have a general notion of what's called vector spaces. Okay, and so there's this interconnection between these ideas that we're going to play upon within this class. Okay, so what I'll do is I'll sort of introduce systems of equations today. We may get to looking at like, matrix notation later on, and then we'll sort of see how everything kind of interacts with one another. Okay, so let's see. Does this go up, down? Ooh. How do we move this? Let's see, does it go this way? No. Oh, great. I guess I have to. All right. Does everybody have everything written down? Okay, sorry.
I do.
So you have to erase there. There's probably a better way to do this. This is really bad. Okay. All right, so let's continue on. So the next thing we need to talk about are systems of equations. Okay. And so there's some important information that we actually need. So there's important data. And so when you have a system of equations, they're going to be linear equations, and you just have to look at, like, first of all, how many equations you have. So first of all, you have to look at the number of equations. Okay. And then what you also want to know is you want to know the number of variables. So those are the unknowns. Okay, so you have the number of equations and the number of unknowns. So let me give you an example of a bunch of these. Okay. So let's look at a nice linear equation that you've probably seen before. So it's example 1. So let's look at 3x plus 2y is equal to 6. Okay, so let's just solve for y on this, right? So here I got 2y is equal to minus 3x plus 6. And then so y is equal to minus 3 halves x plus 3. Okay? And so what does this equation give you in terms of a graph? Anyone? Yeah, but this is an equation of what? A line. Okay? So it looks like a line, and it looks something like this, where your slope is minus 3 halves, and your y-intercepts here is at like plus 3. Okay? So how many values of x and y satisfy this equation? Sorry, infinitely many, right? They're basically the points on this line. Okay? So there are infinitely many solutions. Okay? And so now, how many equations do we have here? Just one, right? So there's one equation. How many unknowns? 2. Okay, so this is an example of a linear system, just one equation itself, and it's one equation with 2 unknowns, and it has infinitely many solutions. Okay. Still trying to figure out, like, if I can do anything reasonable on here. Okay, I don't want to get rid of this. Okay, let me just do this. Okay, does everyone have things written down? Okay. All right, so let me just erase this part here. Okay, we'll just kind of erase this. Okay. And then we could just move on. Okay. Good. Okay, so now here's example 2. Okay, so let's say I take x plus y, and that's 10, and I have 2x plus y is equal to 6. Okay, how many equations? How many? 2? How many unknowns? 2 unknowns. Good. All right. Okay, so these are equations. There are 2 lines, right? This line and let's say this line. So if I ask you what the solution is for this system of equations, so I need points x and y which satisfy both equations. So what do you think we're going to get?
An intersection of a line.
Yeah, how many solutions, or what do you think is going to happen? Well, let's just graph it, okay? So the first equation is like y is equal to what? Minus x plus 10, right? So it kind of looks like this. That's the line right there. The other one looks like y is equal to minus 2x plus 6. Okay, so this is it's down here, but it has steeper slope. Okay. So when you have the solution of the first equation, that gives you a line. The solution of the second equation gives you a line. The solution for both equations simultaneously gives you what? A what? A point. Yeah, good. So it gives you basically that point over here. Okay. All right, so how do we actually see that? So we see it sort of graphically, but how do we see it sort of geometrically? Not geometrically, but algebraically. Well, what we can do is we can multiply the first equation by 2, right? So we have 2x plus 2y is 20. Okay, so this is the first equation sort of multiplied by 2. Okay? And then we have 2x plus y is equal to 6. Okay, now what I can do, and you've probably done this before, is you can just subtract one equation from another. So let's do that. So we subtract. So we get y is equal to 14. Okay? So once we have y equal to 14, what can we do to solve for x? Okay, we can plug it in. Okay, so we can go back up here. So let's say y is equal to minus 14 plus 10, which is equal to, sorry, that's not right. Okay, I'm going to cross that out. Okay, so let's see, the y value is 14. Okay, so that means that 14 is equal to minus x plus 10. I'll be a little bit more careful here. Okay, so I'm using that equation up there. Okay, we're all right with that? Okay, subtract off, so that's going to be 4 is equal to minus x. So x is equal to 4. Okay, so x is 4, y is 14, minus 4. Okay, and y is 14. That makes sense, right? You have to have a negative x value and a positive. Okay, any questions on this? No. Okay. All right, so let's try again. Let's see.
I had one other thought. Maybe if you have the PDF open on this, it'll show up as a shareable option.
Oh, okay. I'll work with it after class a little bit. Okay. Great.
I have
No.
a quick question unrelated to this, actually.
One thing I think that happened was I came in here on Monday. I tried it out. And I noticed that the keyboard and some other things were kind of reconfigured. So I'm wondering if they reconfigured things, things don't quite work the same anymore. So, I'll work with it some more and hopefully we can get it working well next week. Okay.
I actually have a quick question unrelated
Alrighty.
to the
So number 3.
material.
Okay, so here's the third example. So I have x plus y equals 10, and we have 2x plus 2y is equal to 20. Okay, so again, we have 2 equations, and we have 2 unknowns. Okay, so what do you think is going to happen in this situation? Anybody? Yeah, so basically you get the same line. Very good. So this gives you, these are to the same line, right? So basically, so the thing is, all you have is you have this equation over here where y is equal to minus x plus 10, okay? So it's basically the same line. How many solutions do you have? Infinitely many. Good. All right, good. Okay. All right, everyone have this written down? Everybody? Okay. Oops. I will. Okay. All right, so that's number 3. And now let's do number 4 here. Okay, so now I have x plus y is equal to 10. And x plus y is equal to 20. All right, so here again, we have two equations and two unknowns. Okay, so what do you think happens in this case? No solution. Okay, so how do we see that? Well, one of the lines is y is equal to minus x plus 10, right? Okay, so it basically looks like this, where 10 is the y-intercept. And the other equation is y is equal to minus x plus 20. So I have a line which is parallel to this line over here, and this is at 20. Okay, so as you can see, these two lines don't intersect at all, so therefore there's no solution. Yes?
My friend, she's on the Zoom call, and she asked a question.
Oh, sorry.
I think you're muted.
I am,
Volume.
let's see. Is she muted or is,
I think
Can you hear me?
ooh, okay.
she's going like talking.
Are you talking right now? Hello?
Yes.
Okay,
Can
let's see
other
if we
people
get
in the
this to
Zoom
work,
hear
too.
me?
Jeez.
Yeah, I
Okay,
can
so
hear you.
Yeah, I can hear
they
you.
can hear
Okay.
me.
Got it.
So. Oh, boy. Okay, tell you what, can you write it in the chat?
Sure.
Have her write her question in the chat.
Got it.
And her name is,
Shannon,
okay. These lectures are recorded, yes, and unfortunately, so this is an answer to her question, but the lecture is being recorded. And unfortunately, all our sort of foibles are recorded too today, so. But they will be available, yes. At least for 30 days on Zoom, and hopefully more indefinitely in Kaltura. Okay, so does she have a, I'm looking at the chat right now. She ready? Okay, so someone wants me, okay. Okay, so I can't hear you right now. So let me see if I have any options that say anything. Let's see, sideways, stop participant sharing. Doesn't look like a good thing. Let me do this. Let me go to participants here. Oh, come on. What's this? Sometimes if I go to participants, I can unmute people here. No. Here we go. Okay, so let's see if I can unmute somebody here. Okay, let's see. Shannon. Okay. So I actually have her unmuted right now. So that's kind of weird. Let's see. Let me,
Can you hear me?
okay.
Yeah, everyone, I can hear you.
Okay. Is the sound on now?
Yeah, can you hear?
Can you
Okay.
hear us?
We can hear you guys now.
Oh, okay, perfect.
Okay, that works.
Okay, great. All right, so we fixed something today.
Okay, thank you.
Okay, is that much better? We hear you.
Yes.
Yes, it works.
Okay, great. Thanks for saying something. Okay, is everything good now? At least it's starting to improve. Thanks for your patience, because you know, this is a learning experience for everybody. So, okay, great. So let me just kill the participants here. Okay, any math questions so far? Okay, good. All right, so now let me do a summary. Okay. All right, so here are the three cases that I went over. Okay, so what could happen with like two equations and two unknowns? Well, we can have a unique solution. So what we can do is we can have two lines here and they intersect at one point. Okay, so we've seen an example of that, right? Where the lines aren't parallel, they actually intersect. Another possibility is that we have one line and it's basically the same as the other line too. So we just have the same line. Okay? So this is there's one solution here. Here there are infinitely many solutions. Okay. And then the other case we have is if the two lines are parallel. Okay. So if they're parallel, they have no solution. Okay. Sorry, my lines are totally straight. I think you get the idea. Okay, any questions on this? All right, so the next thing you should be asking yourself is, okay, we know what happens with two equations and two unknowns. I mean, this is something maybe, we sort of looked at in high school or something. So what do you think the next question should be?
When does it get hard?
Yeah, when does it get hard? Very good. So the idea is that we want to increase the number of unknowns and we want to increase the number of equations. Okay, so let's try to do that and see what happens. Okay, I swear I will have this hopefully figured out on this new machine. Okay, so let's start with this one. Okay, so let's look at the case with three variables. So it's pretty hard to describe other equations. So you've seen this in calculus. So let's see, let's look at equations of planes. So let's say I take 3x plus 2y plus 4z is equal to 6. Okay, so this is the equation of a plane. Okay, so let's think about how planes can intersect. So let's just say this is the sheet of paper over here. Okay, one sees the sheet of paper. So if I take one sheet of paper, and if I take another sheet of paper, what could happen in terms of, I'll try to do this here. So what could happen in terms of the sheets of paper? They intersect, and what do you get? A line. Okay, so I can have a situation where I have a plane here, and if I take another plane here, like for example, I can get a line as the intersection of the two planes. So I get two equations of planes that can intersect in a line. Now, if I intersect it with one more plane, I could just get a point, right? So if I have another plane over here, then the intersection could just maybe be a point if I have the intersection of three planes. Now, I can also have the planes not intersecting. So here I have like one solution. So I could have two planes, and let's say they look like this. And I could have the intersection be a line. So this has infinitely many solutions. Okay. And then just like with the lines, I could have parallel planes and have no solution. Right. So we can have something like this and something like this, and this would have no solution. Okay, so now you can kind of imagine that when you increase the number of variables, increase the number of equations, well, this is what linear algebra is about. We want to know what the solution set is for these equations. Okay. So the goal in linear algebra is to find the solution of linear equations. Okay, that's one of the goals. Okay, questions? Comments? Okay, now it's kind of a pain to write out these linear equations. So what we want to do is we want to find a more compact way to actually express systems of equations. So what I'm going to do is I'm going to go back to the notion of vectors and sort of show you how to actually write things in terms of vectors. And once we do that, there'll be sort of a clean way to express things. Okay. So let's go back to the notion of vectors here. Okay. All right, so simply put, again, you've seen this before, I hope. So here's like the XY plane over here. So a vector is just like an arrow, right? An arrow that can be sort of moved around. So this is an arrow at the point XY. So, so this vector here, and what I'll do is I'll write this in terms of a column. This is going to have the coordinates x, y. Okay, so if you have a vector up here, what sort of quantities or sort of qualitative sort of aspects do we have to sort of know about this vector? Okay, we should know about the length, right? And what else? Direction. Very good. So, you know, once I specify the length or the direction, then I actually can write this vector out, right? I can, once I have this point, I can also write it out too. Okay, so the typical way we write vectors here, I might write this as V1 and V2. Okay. Now, what can we do with vectors? Well, one thing we could do is we can add vectors. So if I take V plus W, we can sort of add the coordinates and get a new vector. Okay? And so what does that mean geometrically? Well, what it means is that if I take a vector here, V, and I have a vector here, W, I hope I'm not writing too small. Okay? Then what I do is I sort of move the W over here, and the resultant vector is V plus W. Okay? So that's the way I can add vectors. That's what this interpretation is. Okay. The next thing I could do is I can multiply by a scalar. So if I take a constant c times a vector, this is going to be equal to CV1 times CV2. So what I'm doing here is I'm taking my vector v, and when I take c times v, what I do is I just stretch it, or I shrink it, depending on what the constant looks like. So here I would sort of extend it out, and that's c times v right there. Okay, any questions on what operations we could do with vectors? Vector addition, scalar multiplication. Okay, so now what I want to do is I want to take my system of equations, and then I want to put this in vector notation. That's what we want to do next. Yeah, I was already set up to, I have this like nice notepad, and then what I can do is I could sort of scroll it, you know, and keep on going down, and I could come back and forth. But with this, it's gonna, anyway, I'll try to work it out. Okay. So let's go back. Oops. So I want to go back to equations. Okay, so let's go back to the example we had before. We have x plus y is equal to 10. And we have 2x plus y is equal to 6. Okay, so this is a system of two equations and two unknowns. Now, what we can do is we can sort of express this in terms of vectors. So let me write it in terms of a vector form here. So the vector form is the following. So you kind of just read things down the columns. Okay? So it's x times 1, 2 plus y. And what vector should I put here?
1, 1.
Very good. Thank you. And the last vector should be what?
10, 6.
Very good. All right. Okay, so now you can actually see that we've written things in terms of vectors. And so what does this mean? Well, what this means is that when I take the plane over here, let's call it the x, y plane, and if I plot the vector 1, 2 here, so let's say 1, 2. So let's say this is, let's call this vector v just for short. And let's call this w. Okay, so w is 1, 1. Move what? Okay, so 1, 1 looks more like this. Okay, so let's say w is like this. Okay? So the idea is that I want to be able to stretch v and stretch w in order to reach 10, 6. So I want to be able to stretch v out enough and stretch w enough out so that the resultant is up here, which is 10, 6. Okay? So as you can see, if the vectors are not parallel, so they're not the same, you know, or they're not, sorry, they're not on the same line, then you could basically do this. Okay, so this gives a different interpretation of this system of equations. So you take certain vectors and you want to see if you can write 10, 6 over here as what's called a linear combination of v and w. Okay, we'll use that term later on. I'll define it more precisely. I just want you to get an idea of what's going on now. Okay, so I have a question for you. So suppose I take another vector other than 10, 6. So can I actually solve this system of equations if I replace 10, 6 by 20, 15, for example? Yes or no? Yeah, so you can kind of see it with this picture over there. Okay, good. All right, let's see, I think we need to end so that you guys can get to the class. So we'll continue this on next time, and I thank you for the Zoom participants. I'm looking forward to seeing you guys on Monday. Okay.
Thank you.
Thanks. All right, so let me
Thank
see if
you.
welcome. Nice to meet you. Okay, so okay. Stop recording. Okay.